This is the second part to the 1.5 lecture, and we're going to do another problem. We're going to do this exercise together. Describe all solutions to ax equals 0, where A is the pictured matrix. I won't read off all those entries. This, I just want you to notice that this is a homogeneous situation. A homogeneous vector equation. And what signals that to us is that 0 on the right-hand side. So we know there is a solution. There's definitely a solution. And the question is there more than one solution or not? Because there's always going to be the trivial solution. So let's go ahead and start working through the row reduction, row operation process and reduce our matrix. So I'm going to take the matrix A and I'm going to attach this column of zeros. That's really the B column, okay, because our B vector here is the 0 vector. And let's start the process, okay? So row operations, here we go. Now, I guess I'm being nice to myself again. I have a 1 in the pivot position in the upper left-hand corner. I want zeros below. So I'm going to take row 2 and replace it with row 2 minus 2 times row 1. Now, I'm also going to take row 4 and replace it with row 4 minus 2 times row 1. Because I know that if I had performed these operations separately, it's going to come out exactly the same if I do them together. So just if you got to convince yourself of that. If you're not certain, just I'm going to say careful here. If you're not certain that the result would be the same if the two operations were performed separately, then don't perform them together. Do them separately. It's always safer if you're in doubt to just do them separately. But here, if I, again, take row 2, subtract 2 times row 1, I'm going to get 0. I'm going to get 0. This is going to stay negative 2. I think I'm going to get 0. This is going to stay negative 3. That's going to stay 0. So the thing is, if I had done this in one step, then I would have just recopied the third row, recopied the fourth row, and then I could have applied this operation, C, to the fourth row in another step. It would come out exactly the same. So I am going to do these two in one line. So I'm going to get 0 here. That's not, I'm doing row 4 minus 2 times row 1. And so I'm going to get 0 again. This will stay 8. 4 minus 4 is 0. I have 18, stays, and I have 0. Okay, so now I got a pivot in my first column, zeros below. I'm working diagonally for my next pivot. I'm not going to have a pivot in the second column because I only have zeros diagonally and down from that. So so for the second row, I have to move all the way over to the third position before I can get a pivot. So I'm going to take row 2 and replace it with negative a half row 2. So I have 1, 3, 0, 2, 0, 0, and here I'm making a change. 0, 0, 1, 0. I'm going to have 3 halves. I get a fraction. That's going to happen. And now I'm recopying. Okay. And what I want to do is I want to get zeros below my pivot position here of 1. So I'm going to take row 3 and replace it with row 3 minus 10 times row 2. And row 4 I'm going to replace with row 4 minus 8 times row 2. Once again, I know the result will come out the same if I did those operations separately, so it's safe to do them at the same time. I'm just recopying my first 2 rows. Now my next row I'm going to have 0, 0. All right, I'm going to have 10 minus 10, 0, right? That is 0. I'm going to have 15 minus 30 halves is 15 minus 15 is 0, and then I get 0. And so I get a row of zeros there. Now row 4, I get 0, 0. I'm going to have 0, 0. I'm going to have 18 minus 12, I believe. I'm going to 18 minus 12 is 6. And then I'm going to have 0 minus 0. Okay. Now what I got to do is, here's pivot, pivot. Because I got this row of zeros, I have to get it to the bottom. So I can interchange row 3 and row 4. So kind of a pain to rewrite all this. And I'm going to have 0, 0, 0, 0, 6, 0, 0, 0, 0, 0, 0, 0, row of zeros. And let's see, I'm almost, let's see, in reduced form, but I'm going to have another pivot position here. So I'm going to take row 3 and replace it with 1/6 row 3. And some of you may notice, like I could have done a couple operations there that would have come out the same if I did 2 at once, and that would have been okay, as long as you're convinced it comes out the same when they're done separately. So I just get 0, 0, 0, 0, 1, 0, a row of zeros. And I have one more operation to get this into reduced form, because I got pivot, zeros below, pivot, zeros above and below, pivot, zeros below, but I want a 0 above. So I have to replace row 2 with row 2 minus 3 halves row 3. And I'm going to do that on another sheet of paper. So 1, 3, 0, 2, 0, 0. And now here I'm going to have a change. I'll have 0, 0, 1, 0, 0, 0, right? 0, 0, 0, 0, 1, 0, and a row of zeros. Now we're in reduced echelon form, and I should be able to read off what my solution is. I have variables x1, x2, x3, x4, x5. Stop, because that last column, that's the B column, that never corresponds to a variable. So I have 5 variables involved here. And I have pivots here, here, and here. So x2 and x4 are the free variables. I have x1 plus 3, x2 plus 2, x4 equals 0. I have x3 equals 0. I have x5 equals 0. And I have x2 and x4 are free. Okay. Now let's express our solution in vector form. So that vector form is going to have an x1, x2, x3, x4, x5 entry. And I have to only plug in either constants or free variables. x1. If I take this equation and solve for x1, I get minus 3x2 minus 2x4. Then I get x2 is free, so I just write x2. x3 is 0, that's a constant. x4 is free, so I write x4, and x5 is a constant 0. Now, I'm going to, I have so two free variables. Notice how I'm going to rewrite this now. I'm going to write each entry as a sum of terms involving x2 and x4 so that I can get this correctly into vector form. So this x2 all by itself, I'm going to think of that as 1x2 plus 0x4. 0, I can just leave as 0. x4, I'm going to think, actually I can think of that as, let's just write 0x2 plus 0x4 for the record. The x4 term, I can think of that as 0x2 plus 1x4. And then the 0 below is another 0x2 plus 0x4. And I don't know why I accidentally wrote those as exponents. Those are subscripts. Sorry. And I just want you to see that we have two separate vectors now. We have negative 3x2, 1x2, 0x2, 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 plus negative 2x4, 0x4, 0x4, 1x4, 0x4. And I just want you to see here how each one of these has a scalar multiple of x2, can be thought of as a scalar multiple of a free variable. So we have x2 times negative 3, 1, 0, 0, 0, plus x4 times negative 2, 0, 0, 1, 0. And that's our general solution, where we have to add the words where x2 and x4 can be any real numbers. So that's our general solution in vector form. We're describing all solutions, but I want to say a little bit more. These are vectors in R5. So the solutions are vectors in 5-dimensional space, and they consist of all vectors in the span of negative 3, 1, 0, 0, 0, negative 2, 0, 0, 1, 0. So writing the span of those two vectors is another way to express that general solution. It's implied that you're taking all linear combinations of these, which is exactly what that general solution statement is telling us. So this would be a much like a fancier way to express the general solution. And what is this? This is a copy of a two-dimensional plane, because it's a span of two vectors, sitting in 5-dimensional space, whatever that is. So what this whole process gives us is it gives us a way to describe these different infinite solution situations. There are lots, infinite solutions can mean a lot of different things. And here we actually have a geometric picture of what that is. So you can, again, the answer's either box. You can write the box this way. That's the general solution in vector form. You need the words x2, x4 can be any real numbers, or you can write it as span notation, which is a little fancier. And that's the end of our second video about 1.5.